You optimize something, it gets faster. You ship it. Then 50 people use it at once and everything breaks. This happened to someone I know running a small SaaS application. Let's call him Bill. His customer, a jewelry shop, was launching 50 limited edition pieces at noon on Friday. He'd built a PDF generation system for receipts and certificates. Worked fine executing one job at a time. The process takes about 2 seconds each, so he made it faster. Changed the worker to process 5 jobs concurrently instead of 1. Tested it with a few requests. 5 PDFs in a second instead of 10. Looks good to me. He shipped Thursday night. Come Friday at noon, 50 people hit register. 50 jobs flooded the queue. A few minutes later, his phone rang. Site's frozen. Nobody can use the application. He opened his AWS dashboard. CPU at 95%, memory climbing past 2 gigs. The queue was stuck at 47 pending jobs. Here's what was actually happening. The PDF library had a memory leak when running multiple instances concurrently. One at a time? Fine. Cleanup finishes. Memory gets freed. 5 at once? Cleanup calls overlapped. Resources never get released. He tested 5 concurrent jobs at once. Generate 5 PDFs. Done. What he never tested was 5 jobs, then immediately 5 more, then 5 more, 50 times without stopping. That's the difference. Testing checks if something works. Load testing checks if it works when everyone shows up at once. He rolled back in 20 minutes. Slow, but stable. Launch was already ruined though. The frustrating part, his optimization made sense. And it genuinely worked. For the first few batches at least. The problem only appeared under sustained load. Something you'd never catch testing by hand. Here's what's interesting. You don't need an elaborate infrastructure to catch this. One script, 10 minutes to run on your laptop. So, before shipping anything that processes background jobs, ask one question. What happens if 50 of these arrive at the exact same time? Not 5 jobs with a break in between, but 50 jobs right now, all at once. Let me show you how to set this up. Before we dive in, here's what we're working with. We have a containerized Go application with a few REST endpoints. Nothing fancy, just a working application. Locally, we'll run our test script via K6 with some visualization tools while utilizing Docker Compose. We'll then move our Go application up to a hosting service so we can replicate testing an app on the internet. So our goal is basically make the load testing frictionless. No complicated setup, no infrastructure headaches. Just Docker Compose up and you're ready to test basically. First, our Go application. I've already Dockerized. Let me show you the Docker file. Pretty standard stuff. Now, let's go to the Docker Compose file. This is where everything connects. Let's start with our backend service. Standard build configuration, nothing special here. Then next, let's do K6. So K6 itself is what we use for the testing. We're using the official K6 image with Prometheus output enabled. And lastly, for visualization, we need Prometheus to collect the data and Grafana to make it pretty. Prometheus receives K6 metrics. Grafana reads from Prometheus. It's a simple pipeline that gives you real-time insights into what's happening during your load tests. Okay, so Docker Compose is ready. Let's write our first test. So K6 tests are just JavaScript files. Here's the simplest possible test. You can get this from a K6 documentation very easily. Let's talk about what's actually happening here. So VUs, or virtual users, are K6's way of simulating concurrent users hitting your application. Think of each VU as a separate thread that runs your test function in a loop for the entire duration. So you can see with 10 VUs in a 10-second duration, we're saying spin up 10 virtual users, have each one repeatedly execute this function for 30 seconds. There are more ways you can configure these test scripts, but we'll focus on something simple today. Let's see this simple configuration in action. So just running this. Then the one's done, let's pull up Grafana to see what happened. So here are just the basic results on here. Alright, so just real quick, before you can see the charts, we'll need to import a K6 specific dashboard. 19665 is the ID for it. And then we'll select Prometheus for its data source. And that's it. Here are the results. To make it easier to use, I'll refactor a few things. We'll start off with removing this hard-coded URL and using a configuration file. Later, I will update the backend URL so we can target our hosted application. Alright, so I've updated some of our code, and this is how our default function should look like. So real traffic doesn't look like a flat line, so let's simulate something realistic. Maybe a spike from a marketing campaign, or maybe a scheduled event like in our story earlier. So I made a few changes in our script. Notice we're using stages now instead of a flat VU count. I use stages on this because it lets you model realistic traffic patterns. We start with 10 virtual users, ramp it up to 100 over 2 minutes, simulating that sudden traffic spike, then you ramp it back down. Each virtual user keeps executing the test function in a loop throughout their lifetime, basically. So I've split our test into two functions. Let's focus on the second one that has some checks. Those check functions, they validate responses in real time. If a check fails, K6 tracks it as a failure metric, but importantly, it doesn't stop the test. Notice the logic immediately following the checks. We only attempt the following GET request if the post call was both successful in status code and passed all its data validation checks. So this basically lets you see how many requests fail under load, not just that something failed. You might find that 99% of requests succeed at 50 virtual users, but only 80% succeed at 200 virtual users. Now that's valuable data. So finally, let's run this against our deployed application. For the sake of ease of deployment with monitoring, I'm using AWS ECS because that's what I'm used to. I'll just load up the ECS dashboard to monitor the CPU and memory utilization. In our 4-minute test, we've forced a spike on the container that's running. Then you can move to Prometheus and Grafana to check the results of the tests. So there you have it. If you've just deployed a new feature and see error rates spiking or response times degrading under load, you'll know immediately and be able to deploy a fix and hopefully avoid a disaster during a client's event. With this approach, you can easily set this up with just Docker images that's already built in a Docker Compose. That's it. Hope you learned something new today.